Greetings and welcome to this video. My name is Parth Joshi, and in this video we will be discussing about blockchain. Blockchain is an algorithm which is behind the distributed ledger technology. It is used in various applications such as the cryptocurrency applications and business network applications. Blockchain is not a new concept. It has been there in the research area since a long time, but it came to light after it was used in one of the cryptocurrency network called the Bitcoin. The applications of blockchain are not just restricted to the cryptocurrency network, but it is also used in various other networks or applications such as banking and financial sector applications, the real estate sector, the supply chain and logistics sector, as well as the voting, elections, so on and so forth. Of course, the applications are not just restricted to this list as well. So let's just try to understand what blockchain is. In this video, we'll be going through a very basic and simple version of blockchain to make our lives much more simpler so that we can understand blockchain very easily. We will not be going through the details and the complexity of the actual real world blockchain or the cryptocurrency networks. So blockchain is nothing but chain of blocks, wherein each block will contain some facts. If we try to compare these facts with the real world sectors or applications like banking and the financial sectors or even the cryptocurrency applications, those facts are nothing but ledgers for the transactions between different parties. You cannot delete a fact from the block of the blockchain, but if you want, you can add new facts in form of adding the blocks to the blockchains. Each block will contain a reference to the previous block, and the first block is known as the genesis block. So in this way, we can form the chain of blocks wherein each block is pointing to the previous block and each block contains some facts or ledger of the transaction. The last block will have the latest transaction in the transaction list. If you want to see the history of the transaction in the complete network, you will start from the last node and traverse it to the first node, since each node is going to have a reference to the previous node. Now, in the real world applications, you will not use a single blockchain. Blockchain applications are generally used in the distributed blockchain network. A distributed blockchain network is nothing but a P2P network, wherein each node or the peer has a facility to transmit data securely to the other node in the network. So whenever a node is added to the blockchain, it will be broadcasted to each and every node of the network. So that means each node of the blockchain network will have the entire copy of the blockchain. So there might be a question which may come into your mind. How do we make sure that a block which is recently added into the blockchain is the genuine block and the data inside it is not tampered with? And to make sure that the data is genuine, we have something known as consensus algorithm. There is a lot of work going on in the consensus algorithm, and there is a lot of research areas inside the consensus algorithm. In this video, we will be going through a very basic version of an algorithm known as proof of work. And we'll be showing a simple version of it, and let us see how proof of work works. Proof of work is an algorithm which requires the machine or a node to generate a value which is, number one, very difficult to generate, and number two, it is also verifiable. So to understand what is proof of work, Let us first understand a basic structure of a block inside a blockchain. To understand the basic structure of block, we will be going through a very basic and elementary set of data for this block. It may not be the real structure of a block which may be used in the real life applications, but a very minimalistic version of a block structure. So this block will contain these many things. Number one, block number. Number two, nonce. So this nonce will be useful for us to generate the proof of work. Data, essentially data is going to be nothing but the ledgers or the facts which will be storing in the blockchain. Next will be the hash of the entire block, and last one will be the hash of the previous block. So this forms a basic structure of one block of the blockchain. Of course, it means that the first block will have hash as 0. So in the entire network or in the entire blockchain, the Genesis block will be the only block which may have the previous hash value as 0. Let us go through one of the open source tool or a demo and try to understand how this series of blockchain functions. Let's begin to explore this open source blockchain demo tool made by Anders. You can access this tool from the GitHub repository mentioned over here. To access this demo, let's just go to anders.com/blockchain and just click on the tab hash. So before going through the explanation of blockchain, let me just try to explain you how hashing has been used in the blockchain algorithm. So first of all, for this example, we'll be seeing how SHA-256 hashing algorithm is used to hash the data of the particular block. So instead of a normal plain text data which I'm putting over here, in the actual cases you will be having the ledgers or the facts which will be storing in the blockchain. And this is the hash code for a particular block or the data of a particular block for this particular blockchain. So let's go to the structure of block. Now the structure of this block is something similar to the structure of block which I had shown you in slides a couple of minutes ago. So in this structure we have block number, nonce which we'll be using for the proof of work, data for the block, and the hash code. Now we can see the block turned red just as I typed my data in this particular structure of block. Now this is because this block has not shown its proof of work. So like I said, the proof of work is a value which the block is supposed to mine, for which the value generation is a bit difficult, and at the same time the value is verifiable. So the criteria for proof of work for this particular block is going to be the fact that it has to find a nonce so that the hash code of nonce and the data is such that it has 4 zeros at the prefix of the hash code. So let's just see how this works. So once I click mine button, it will start from 0, and it will start from 0 and find out the nonce value for which the combination of hash code for the nonce and the data has 4 zeros in the prefix. So this block had started from 0, and at the value 8118 it got a hash code for which the prefix was 4 zeros. Now let's just try to apply the same thing in the blockchain. So like I said, blockchain is going to be the chain of blocks which is going to contain the facts, in our case data, and each block of the blockchain is going to point to the previous block. So let's say over here you will have this pointer of the previous going to point to block number 4 over here. So this is how you have a complete blockchain. The point is that if you try to tamper some data, the blockchain breaks. The blockchain breaks because the hash code of a given block is going to break, and due to that, it will not satisfy the criteria of the proof of work, and at the same time, the previous pointers of the consecutive blocks are also going to change. So this is where you will have to mine the data again if you change the data. So this is the reason why I said that you won't be able to change the data, but you can add more facts in the block as you want, or even you won't be able to delete some facts from the blockchain. So that is one thing. Now, like I said, blockchains are generally used in distributed peer-to-peer networks. So let's click on this distributed tab. And after I click on distributed tab, you can see three different nodes or three different peers. That is peer A, peer B, and peer C having the same copies of blockchain. And if I try to change the data a bit, let's say I try to change data of block number 4 of peer B. I change the data, I mine the data, and once I mine the data, maybe I will be able to get a different hash code. I will change for block number 4. It's taking time because for some data you may have to travel a big nonce number to get the hash code. And I also change the data for, let's say, block number 5. Once I do that, what you will observe is that hash codes are going to change. So you will be able to see that for peer A, for block number 4, you have hash codes which starts from 000AE8, and the same applies for block number 4 for peer C, that is 000AE8, but the same does not apply for peer B. So it's a kind of a democracy over here. They will do a voting from based on some kind of a consensus algorithm, so on and so forth. And based on that, they will decide that copy of blocks 4 and 5 for peer B are wrong. So they are going to replace the entire copy of blockchain of peer B with the one of peer A and peer C. So this is how they are managing the data, and they are making sure that no data is tampered in the blockchain. So I have made one Python code which simulates the same thing which we have just seen in the Anders demo. And to access that code, you can simply go to github.com/JoshiParthin. You can just go to the repository tabs and just go to Python Playground, and in it you have a blockchain folder. Inside it you have a block.py file. So you have this Python code which tries to simulate the same blockchain demo which we have seen of the enders on the GitHub code, and you can just download this code. You can simply uncomment this particular statements over here and try to just play with it and just try to see how I have simulated the blockchain network code, the one which you have just tried to see right now. So I hope you might have liked this video, and if you have further questions about blockchain, please feel free to reach out to me. I hope we had made this video in a way that it would have been easier for you to understand and get started with the basic concept of blockchain. Thank you.